Hello guys, welcome back and thanks for stopping by. Main focus here today is testing this pressure switch and seeing how it works. This pressure switch here is used on a rooftop unit for the air conditioning side. It detects low refrigerant in the case that refrigerant would leak out from the compressor would not run dry and burn itself out. So it acts as a safety device for the compressor. This pressure switch opens up at 5 psi and it closes at 20 psi. So that means that at 5 psi, the switch inside this opens up. And at 20 psi, the switch inside here will close. And what I mean by open, there will be no continuity flow from this wire to this wire. And when it closes, there will be continuity from this wire to this wire. And continuity just means that there's a path for electricity to flow. I plumbed an air fitting into the pressure switch, and I hooked up the switch to my air line. I won't be testing this with refrigerant, so I'm using air pressure as a substitute. So setup for today, I have my air line with a regulator. It has no air pressure right now. It's at 0. And then I also wired the switch to a light bulb to show how the switch opens and closes. When the switch opens, as if right now, the light bulb is not on, and once the switch closes, it then allows a path for electricity to flow to the light bulb, and the light bulb will light up. And my power supply. Let's turn it on. Have it set to 12 volts because that is a 12 volt light bulb. So let's give it a test. So right now the switch is in the open position because there is no current flow to the light bulb. And remember, the switch closes at 20 psi. So if I turn my air pressure up to 20 psi, there it is. We are close to 20 psi. My gauge might be a little bit off because it's been banged and the screen is broken already. The switch is now closed and the light bulb is on. That tells me the switch is working. And when I drop the pressure, let's say there's a refrigerant leak and pressure drops, there's no pressure because there's no refrigerant in the system. Voila, the switch opens back up and it cuts off continuity to the light bulb. Let's look at it one more time. Switch closes, light bulb turns on. Switch opens, light bulb goes out again. And here I have a simple diagram circuit of what I have connected here. So 12 volts power supply, that is this guy, wired. The positive side is wired to one end of the pressure switch. This is the positive side, and as you can see, the red wire, it comes and it is wired to one side of the pressure switch, and then coming out from the other end of the pressure switch, it goes to the light. As you can see, coming out from the other end of the pressure switch, it is wired to one end of the light, and then coming out from the light is the negative side, going back to the power supply. And then there it is, coming out from the other end of the light, goes back to the negative side, and it returns through this back lead to the power supply. And electricity is just flowing in one continuous loop if that switch closes. But right now the light bulb's not on because electricity comes out from the positive side, but is then halted because it is open. There's a gap from this switch to this wire, not allowing electricity to flow, thus preventing the light bulb from turning on. And that is all. I hope you found this information useful, educational. Please like and subscribe if you enjoyed it. Thank you. Thanks for stopping by.